Okay? So on our examples, the first type of a problem we're going to have is a triangle that we're going to try to find all the missing parts by using the law of sines, law of cosines. But we have an issue, right? Because I told you your test is going to be based on here's triangles, find the missing issues. And you're going to have to determine when to use the law of sines, when to use the law of cosines. And what we talked about on our homework quiz, that we can use the law of sines when we have a, Zoe, you remember? Kristen, you remember? What do you have to use the law of sines? Yes, Caroline? You have to have a ratio to then, because once you have a ratio, well, at least two ratios, but once you have a ratio of its side and its angle, you can apply a proportion. You can create a proportion that will help you solve using the law of sines. The problem here is we don't have any proportions. That is, one proportion. We have sides, but then we don't have the angle. Side, no angle. Side, no angle. So we cannot apply the law of sines for this problem. All right? So we have to go and apply the law of cosines. All right? Now, there's three different laws of cosines for each angles. There's different ways to manipulate it and solve them. All right? On your formula sheet, though, they only provide you one, which then you can manipulate however you want to use it. So I will provide you guys with all of three of them. So if I say a squared, that would be b squared, all right, plus c squared minus 2 times b times c times the cosine of a. All right? That is one of the law of cosines. But we can now manipulate this with all of the sides. So if I said b squared, that's going to be a squared plus c squared minus 2 times a times c times the cosine of b. And c squared would equal a squared plus b squared minus 2 times a times b times the cosine of c. All right? So please note the formula that's on your formula sheet is incorrect. All right? So please make sure that is updated so you guys have that and it's correct on your formula sheets. So if you have the side, you're going to take the cosine of that angle, and then the rest of the sides inside there are going to be the other two that you are not solve for. Now, obviously, we can manipulate this, and what we're trying to do is we're trying to solve for an angle. So you might say, well, which one do we use? And the fact of the matter is it doesn't really matter. However, there is something that we want to make sure we go through on this, is we can choose any of these sides, right, to use, right, any of these sides. However, what you guys want to do when you're applying the law of cosines and you do not have an angle to go off of, always try to choose the largest angle possible. Because remember what we say, we don't want to have an angle. Like, remember when we have a triangle and we have one angle? If that one angle is 20 degrees, then we know that the next angle could be the obtuse or the acute side of it, right? So you could have two cases, correct? We don't want to get into that issue. We want to try to find the largest angle possible, hopefully an obtuse angle. So out of all these angles, which one do you guys think? Obviously, the triangle is not written into proportion, scale, yes. But which one do you think is going to produce actually the largest angle or obtuse? Yes, Garrett? A? Well, think about an angle. If you guys have an angle, the larger the angle, the larger the side? The larger the angle, the larger the side. The smaller the angle, the smaller the side, right? So the larger the angle is going to have the largest side. So what is the largest side? Obviously, 18 is the largest number. The angle of that is going to be b. So therefore, the formula that I'm going to want to use is for b. Correct. All right? Now, I know on your formula sheet they solve for the cosine of b, which is perfectly fine. We can just do the algebra, though, by ourselves. It's not a big deal. So we know what b squared is, which is 18. Or we know what b is, which is 18 squared. We know what a is, which is 5. And we know what c is, which is 3. But the only thing we do not know is the angle of b. All right? So I know, guys, this is like a small step. But I'm telling you, if you're going to make a mistake, a lot of mistakes that I see from students is they just don't plug it in. They just want to plug everything into their calculator, and then they make a mistake as they're entering information in. So this is a very small step, but just take it step by step to make sure you have this in correctly. So now I do not have 18 squared memorized. I'm sorry? What? Exactly. Or to have it correctly. To have it correct. So 18 squared is 324. We obviously know this is 25 plus 9. Minus 2 times 10, so it should be minus 30 times the cosine of b. So 324 equals 34 minus 30 times cosine of b. Now again, remember, we're trying to isolate the b, right? So let's apply our inverse operations. So therefore, I will subtract a 34. So therefore, I have 290 equals negative 30 times cosine of b. Then I take 290 divided by negative 30, and I get a negative 9.66 equals the cosine of b. And I take inverse cosine, second answer, and that does not work. So therefore, you can see that this would be a case where you cannot have no triangle is going to exist. Because now, when you take the cosine of inverse of negative 9.66, repeating, that equals b. However, that is not within the constraint, so therefore that is no triangle exists.
You have to do all that work to find out.
Oh my god. Wait, so you do the inverse because it's negative?
Huh?
It's a negative 9, so you do the inverse?
Yeah, you do the inverse cosine of negative 9.66. And since it's not within the domain of the inverse cosine, therefore no triangle exists. Okay?